Okay, as I'm the first one of the speakers, I thought, because robust detailing, robust buildings for me starts with the design. And that's why the title, Delivering of Mass Timber Project, Integrated Design, the Way for Success. For me, this is really important because it starts at the table thinking about it. I want to talk a little bit about what we do as Eurban, just a brief introduction how we work. Then for me, two extreme important things are BIM and DFMA. And then I want to show you how we use it in our office, how we go through the process, how we detail everything, and then prove some examples, some details. As Nick already said, we are the oldest mass timber company in the UK. We were founded 15 years ago out of a need because we were where you guys are now or where you were 3 years ago. We had this brilliant product, CLT, glulam and all that, but nobody really knew how to use it. Who can design it? Who can build it? Architects loved it because it's easy to understand. They had the vision what they can build with. The contractors saw, yeah, it's a great product. We can build faster and therefore more efficient. But who can I give the job? And that's why we established ourselves as specialist timber engineer and specialist subcontractors. We work all over the UK, but also now more and more internationally. And we prize ourselves as one of the leaders in high quality mass timber buildings. We like to be on the forefront and use digital technologies like BIM and DFMA. We are going more international. At the moment, still only in Europe, but we have 3 offices. Our headquarters is in London. We have a small office in Scotland, in Inverness. And then we have a new office in Switzerland, which we just opened a year ago. And that is now expanding. That's also where we do most of our international work. This is really what we do. We are a mass timber specialist, or in the UK we call it solid timber, but it's exactly the same. We have the 3 keystones, which is the design and the engineering, the manufacture and the assembly. With the engineering, we do that all in-house. We employ structural engineers, timber engineers, project designers, architects for the project management. And that's an important thing. We're not just engineers. We're also solving acoustic, thermal, moisture, all the building physics. And then we think about, on the beginning, how to install a project, how to manufacture. The interface details with other follow-on trades, how to make the robust detail, that the waterproofing works, that the waterproofing also works in 10 years, 20 years' time, how you can maintain a building. And then a collaboration is extremely important. Collaboration between the design team, you have to take the architect on board and the other engineers, everybody else, that they think from the beginning about timber, how to use it, how to detail it. And then the collaboration with your supply chain, because we don't produce, we buy everything in from Austria, Germany, Switzerland, France, wherever the material comes from. We choose the best material for every project, and that's important for us. Or we have long-standing relationships with some of our suppliers. Others are newer. We're also open to others and also to new materials, prefabricated cassettes, and we also use steel. Or we are timber guys. I'm a trained carpenter. I grew up with timber. That's my thing. But steel is still a brilliant material. And if we can enhance the timber structure with a bit of steel, let's just do it. Also, concrete is a brilliant material, but usually it belongs down to the ground. That's where we need the concrete. Or because we want to keep the timber away from the ground, away from the water, again, to protect it, that it will be there for the next 500 years. Or I grew up in a country where we have a lot of old timber buildings. I grew up in a house which is 250 years old. There's timber in there which is 250 years old, and it's still okay because it was detailed robust. It was detailed in the right way. And that's what we try to do here. Also the quality control, because we are quite close to our suppliers. We can go there, we can check stuff, we can do quality control from the design into the supply, but then also to the site. And one of the reasons is exactly to have this full control, to have our own installation team. We employ our own carpenters on site. It's a high-risk strategy. If you ask a risk manager, they will say, no, leave that. That's where you lose money. That's where the risk sits. But for us, it's important because we get also this closed loop. People talk to us back when something is wrong, a detail isn't properly done. They tell us and we can learn from it. Oh. And we do more and more 4D construction simulation. Again, the quality management, we can manage the tolerances. We can manage moisture, because moisture is not only when the building is finished, it's also when you build it. And then the lessons learned, the closed loop. That's why we have these 3 cornerstones to our business. We have quite a lot of experience. We've done over 280 projects. We have a counter on our new website. If you want to visit that, it goes up every month. Sometimes I would hope it goes a little bit faster, but the most important thing is to have happy clients. And I never met one client who said, never, ever again. Some of them said, I thought it can go faster. But usually it's because, I forgot to order the windows. And yeah, my follow-on trades were not ready. But a lot of our clients are repeat customers. Or some of them, they do the 4th, the 5th project with them. One of our big clients, they give us one school after the other because they say, we don't care. If we give it to you, we know what we get. And we improve together with the client. We learn from each other. Or just a little timeline of projects we have done. Everybody's talking about the multi-story market. Yes, we haven't done an 18-story or a 20-story building, but we heard that this morning a few times. The sweet spot is between 5 and 12. I completely agree. That's also where we do most of our projects. These are just a few of our multi-story projects we have done. But interesting enough, these 2 projects, the last 2, that's the client for this project is a concrete frame contractor. He's moving away from his own concrete business because he wants to become a main contractor, he wants to grow, and he can see CLT or mass timber is a good addition to his offering. Then we've done other projects as well, or the whole CLT boom really started with schools in the UK, because we had the program in the UK that we want to build more schools. And that's what we did. We built a lot of schools. We done some civic buildings. You can see that one is it's an assembly hall which is egg-shaped, completely out of the norm. The steel guy said, yeah, we can do it, but it costs you that and that amount. The contractor said, we can't afford it. What is the solution? And the timber was cheaper because it's a prototype. And we can do prototypes much easier than the steel industry. We want to go and do serial production, proper, where we can do the same again and again, but we can still do the prototype. And even if it looks like a prototype, the processes are exactly the same, and then it doesn't matter. That's the most important thing. On that, it really comes down to BIM. We all know building information modeling, but it's also building information management. And that's why we call it quite often, it's better information management, because that's what it is, that you get the right information at the right time, that we are talking about the right things at each stage. And it's not just drawing a 3D model, because it's information about the product, it's information about the life expectancy of a product, warranty, everything is in there. And then you can link it with others. You can work collaborative. You can design it with the design team. You can integrate others into your team. And that's what, for me, means integrated design. It's not just us internally, that we work as a lonely group and we do everything perfect. We have to integrate with others. And that's what we do more and more with BIM. We take architects, other consultants onto the journey from the beginning on. We give them our BIM object. We give them our model early on, because a lot of them, they don't know. The simple question, what should I put in? How should I model CLT? We say, look here, there is a template, just do it. And then you work together. But that means you need to involve the specialist early on. And that's an important thing. Or for me, BIM is a different way of working. It's no longer that we draw a drawing, we put it in the post, send it over, and a week later you get some markups back and then you do the same. We have all this technology, but the most important thing is we still need to talk to each other. Oh, that's a brilliant thing now. You can talk over Skype and all that, you can see each other. But for me, on the beginning on a project, I still want to meet the people. And that's what our guys in the office, they also want to meet each other, because then you understand what is everybody's need. And that's an important thing when you start a project. Ask, what do you need, what do you want, and what you don't want? Because it makes no sense to send somebody information in a model which is useless for them. Oh, find out what you need. And to be honest, BIM, we're in the timber industry, we do that since a long time, but we do a lonely BIM. We're not really integrating others. We're really good in making our processes really efficient. But we have to take others onto the journey as well. And we all know if we spend £1 or €1 or $1 at the design stage in the BIM, we can save $20 at the assembly. That's the BAM. That's the building assembly model. But that $1 turns into a much bigger thing, into 60. And that's the BOOM. That's a building operation optimization model. So if you save money on the beginning, it will become much bigger because it's much simpler. And that's why integrated design is really important, and use DFMA, design for manufacture and assembly. Think about that on the beginning. Oh, it's not only how the building looks, it's also how we procure it, how we manufacture it, and how we put it together. And again, you need to collaborate. Or not everybody has everything in-house. But if I look in this room, I don't know you all, but I know there are certain people who can help me, and I can help them. And if we work together, you can deliver a project much faster. And that's for every project. And again, it's a different way of working. We have to share. We are really good in keeping everything together and not giving stuff away. And in the timber industry, as a carpenter, if you draw something, you always think, oh, how can I cut that? How do I put it together? How I put the nail in? That's why it is important. The idea comes first, the planning, the delivery, assembly, operation, and more important for the future, the disassembly. Because unfortunately, we don't build buildings anymore who last 500 years. Not because they're not built correctly, because our needs are changing. That means we have to change the use, we have to reuse it, we have to recycle, and that's more and more important. There will be a point where we as designers have to come up with a strategy. What do we do with a building in 50 years? I want to remodel that school into an office building, or that office building into residential. Future-proofing, it's a huge word, everybody wants to future-proof. What future-proofing means at the moment, we just do clear span, 100 by 100 meter. Yeah, we can do it, but it costs you a fortune. Should we not think a little bit more intelligent? And this slide here shows you really, if you spend a small amount of money in the concept, you can save or you can influence so much for the whole project. We all know that. If you go down in design, the expenditure gets bigger and the influence gets smaller. At the construction stage, if we want to influence something, we spend a lot of money and we can't really influence that much. And I think everybody knows that curve. The opportunity is so much bigger in the beginning. But it needs to go into people's mind to collaborate, to work together in the beginning. Maybe spend more money on your design team and get that done. Otherwise, we will struggle to do proper integrated design. And this is a slide from the UK, from the RIBA, the Royal Institute of British Architects. We have, in the past, it was always like, it was one line, stage 0 to stage 7, strategy, brief, concept, develop, technical development, construction, completion, use. Now they closed it to a circle, because a building is in a circle, as I said before. when it's in use, at some point we will change it. And that's exactly what we have to do. And that's how you should work with your team. You should involve your team from the beginning to the end. Unfortunately, that's how the UK model looks at the moment. We only get involved really late. There is a lot of design work already done, a lot of money is already spent, and then people say, oh, can you please turn that in one of these lovely mass timber buildings? And as we remember the graph before, opportunity gets smaller and smaller. And that's why we're saying you have to think about that. You have to integrate that into your design team, at least at concept stage. Because at that point, you can still influence. But better if you get in from the beginning. Because if a client comes to you and said, look, I want to build with timber, then get your timber specialists involved. Because then you can maybe change a little bit the shape or whatever. Or again here, this is put back in a line. Usually we get involved here at tender, and already here we have to sign off the fabrication drawings. But there is so much more you can offer on the beginning. Lessons learned, you can think about the site, the structural strategies, and then smaller stuff like halls and all that. How to do that. And this is how we do it. This is our process. This is our storyboard, our BIM storyboard, or how we really work. If you look at it, it's overlaid with the RIBA stages. And I want to go through that quickly, how that works. We don't have too much time to go into much detail, but that's how we start. Every project starts with a concept, with some sketches. That's all done manually on a piece of paper. But then we're already starting with our model. We maybe take a model which is already there from an architect. And this example project is an 8-story building which we did in London. Or we take the architect's information, turn that into our model, put the structure in. We're already producing some drawings, and then we work through the whole building, and we can give that information out. We can do the first coordination. From that model, we also produce a material takedown that we can fix the price, because everybody's asking you, oh, what is the price and how long it takes? And this is a really important thing. As soon as we have the project, we move on, we develop it still with our model, but we integrate it into our FEM model, into our calculation model. Or we can do different things there. We can componentize it. We put the loads on. Then we do our engineering. All the snow loads, the wind loads, your earthquake loads, whatever you have. And from that, you're calculating all your different components, and you can see it's the same model. At the same time, we're using that model. We're putting still 2D drawings down because people want to see that. That's how we're used to. And at that point, we're also doing details. Our details, how to put the CLT together, but also how it works, the interface details. And that's where we also use our specialist panels, our BIM objects. And then we coordinate it with the concrete, with the M&E. Then we put our timber on top, and that's how it works together. You can see all the little pictures, and that's how it should work in reality as well. Then with the cladding system, with the windows, that you can order everything before we even start on site. That we put up the timber and they follow us really quickly. Or prefabricated walls, it's a really good thing, but on a lot of projects they are not ready there, and they want to use a more traditional approach. You can do that. If you program it properly and you design it properly, it really makes sense. Or at this stage, we do our first 4D simulation to show people how the building will go up, that they can plan their stuff. Then again, we do a cost monitoring, that we can see if the costs are going up or not. And then it's the whole coordination, where we have our models, they're running through, we're developing there. Then it goes outside to our design partners, and as soon as they're happy with it, the model goes into the design freeze, and then it gets transferred into our supply chain. And from here, we're taking the model, we're splitting it up again, or where we panelize it. We have some special tools to, for example, here for the CLT, how to panelize the CLT. And we have all that done. That's all automated now. And then we have one model where we have all the CLT in it. We have another model where we have the glulam, and then a third model where we have the steel, and then we have lists where we order the fixings. And this is really, really simple from the same model. From the same model, we are also using that for our assembly drawings. These are 2D setting out drawings, but also 3D drawings. It's like an IKEA system. And that's what the guys on site, they like that as well. And then again, you show them the details. And then on the end, it's that 4D model. But now, what is really important with the integrated design, with the detailing from the beginning, we have to think about structure, building services, acoustics, fire, thermal, air tightness, moisture, all the follow-on traits. I don't really have time to go through everything. I just want to show you two things. One is really important, is the interface to the concrete. You have to communicate that with your team, with your contractor on the beginning, that they know what they have to deliver. Then you have to go and check it, that they can change stuff. We usually do that 2 weeks in advance. It sounds a lot, but they can then mitigate some mistakes because it's about tolerance. The concrete is never flat. But what do? We don't want to check up the building too much. That's why we give them usually tolerance plus 5, minus 15. And then you have these different details. One is the easiest, clearly, it's if the CLT sits on a concrete slab. On an upstand, in some areas you need it to get the timber out of the ground, but it's a little bit more complicated. Then you maybe develop some special brackets as we've done here, or you use standard brackets, but what you need to consider is here, it's the tolerance, and you will have that. And think about that you don't need to solve that problem on site. Solve that on your table in the office. The other thing, the last thing, is really the M&E. It's really important, all the services, because that's what we want, not this one, that they have the pipes and say, oh, but your beam is in the way, what do we do now? We can solve problem, we can cut holes, but we don't want to do that. We want to pre-plan that, because that's also robustness, that not everybody goes around and drills new holes. That's the downside of timber, that everybody can drill a hole. But it's also a plus side because you can if something is missing. And again, we talk to people early on. We tell them what we need. We have some briefing notes where we show what is allowed, what is not allowed. And then it's important, where do you have your services? Do you run it in the structure? With CLT, it's not really possible. You need to have it on top or below. And that needs to be coordinated on the beginning. Because then it looks like this. The yellow cable, it's just a temporary one. But you want your cable rectangular. You want to know where your cables are. It's exactly the same in the walls. Ideally, you do this. Don't route the stuff out because it's the bottleneck is the CNC machining. I have also a video here. I will not show you that, but if you want to see it, you can go on to YouTube. Should I show it? Yeah. Okay. Good. Good. Then, oops. I need to type it. What it is, it's our 4D model of that project I showed you before. It's not only a 4D simulation, it's showing the reality. It's really the model, how it goes up, what gets delivered. You can see we have upstands, we have a lot of brackets. Then we have the panels coming in. Some of the panels they're pre-lined with gypsum fiberboard for fire. We put all the bathroom pots in, and that's important. They need to go in before you put the lid on. Otherwise you have a problem, because you can't take this apart and put it back in. And all that stuff, if you show that a contractor, they will say, oh yeah, that's great, but that's not how it happens. Or this is why we do this. That's the reality. Compare that to the animation. That's exactly how it is. The benefit is this building was built in 2 phases. That means we were able to do this in phase 1, show them the 4D model again and the reality. And it is quite clean, it is quite dry, all that stuff. On the first phase, they didn't believe us. On the second phase, they were chasing us. When we installed the last panels on the top floor, they had all the windows in, all the insulation, all the cladding on, up to the 3rd floor. You can see they learn from it. And this is important. And now they ask us on every project, oh, can you do that, please? Can we have that again? Because we have to show it. And this is the important thing, that you show people how it goes together. This was our biggest marketing piece. Up to that stage, our website was 10 years old. And everybody's saying, why you're not doing a new website? And we said, come to us, visit us. We go to site and we show you how it works. And that's what we did. Now we have a new website. If you want, you can go and have a look. That's how it looks. I have also a little brochure if you're interested afterwards. But this is really what we do, with using technology, but using also skills. And for the end, it's really for me important to say the early appointment, the early input from a specialist to design in mass timber it's adamant. The DFMA approach to get all the cost benefits what mass timber can deliver you, and then collaboration, enhanced collaboration in your team, that everybody works together. And digital construction, there are great guys out there, for example, Cat Makers, they're doing a huge job. They've done a great job on Brook Commons. Get people like them or us involved to help. That's important, because with experience, you can help everybody, you can make the details more robust, and your building more robust. Thank you very much.